back to rates of change. Actually, as I'm doing the first example, you'll wonder why this is called rates of change, because I won't really do rates of change. That doesn't come up until the second part of the example, okay? For now, you can just think of this as, let's review graphing, shall we? A fairly simple graphing one, not the worst one. 3 sine bracket x minus pi over 6, sketch the graph over the domain 0 to pi. They want me to graph it. Well, here's the steps. If it was sort of foggy to you up till now, here's the steps. Here's what you want if you want to graph this thing. I think you want the amplitude, which I'll just use the letter A for amplitude. It's easy to find if you know where to look. If you don't know where to look, well, you're going to look. Right out front there. The amplitude of this thing will be 3. So it'll be a sine graph, but it'll be a sine graph that goes up to 3 and down to negative 3. Instead of up to 1 and down to negative 1, up to 3 and down to negative 3. Then we need the period. Now, in other questions, I didn't do it in this one, but in other questions, what you'd need is that fancy formula. You'd go 2 pi divided by that k multiplier. Usually you find it right in there, whatever that number is out there. So it'll be a 2 or a 3 or a 4. We don't get too crazy with this. You won't see a 7.2 in there. There'll be some number out there, and you divide to get the period. You go, okay, 2 pi divided by that number. But in this case, it's just the number 1. There's been no horizontal compression or stretch, so the period of this thing is 2 pi. I like dividing this in 2 pieces. Once you know the amplitude and period, you can get a pretty good graph of this. There are 2 other things you need to know. You need to know the vertical translation, because after I do my initial graph, I might move it up or down. This one doesn't have any. There wasn't a number out here to move this up or down one after it was all over. But there was a phase shift. Pi over 6, right. So I got to keep that into account. But me personally, I find these graphs easier if I first make a graph that has the right amplitude or period, and then I shift it over. I just take the whole graph and move it up and around like that. I find that easiest to visualize. You know what the toughest part is? None of that's the toughest part. You do a few questions of homework. I mean, there's lots of homework provided for this. Even if you do a handful of them, this is not hard, making this list. This is the decision that can cause you heartache. It's the one you got to get right. Here's a little hint. Pi over 12, in all the homework questions I know of, if you just use pi over 12, everything works out well. That's sort of a cheater hint for grade 12 advanced functions. Pi over 12, I don't know what scale to use. Use pi over 12, it'll all work out, everything will be fine, yeah? But we can do better here. I know the period's 2 pi, so when I see that, I'm sort of thinking, if I take 2 pi and divide it into 4 pieces, pi over 2 is sort of the scale that would make the most sense for that. Just take the period, divide it into 4 pieces, because sine and cosine graphs sort of have 4 pieces to them. They go up, back to the middle, down, back to the middle, and then they're done. So there's sort of 4 pieces. That's why I go divide by 4. So pi over 2 is sort of what I'm thinking. But when the phase shift says pi over 6, pi over 2 is not going to be a very good scale. So the trick is, get the phase shift, take the period divided by 4, and just get the common denominator between them. And if you're like, why are you getting the common denominator? Why are you saying that? Watch, you'll see. It works out so good. Here, the common denominator between 2 and 6 is 6, so I'm going to use a scale of pi over 6. It really looks like pi over 6 is a great scale. If you're not convinced, wait till you see what happens when I graph this. If you make sure the scale incorporates both of these 2 denominators, things will work nicely on the scale. I'll show you what I mean. Here I go. I've decided on a scale of pi over 6. They only want me to graph from 0 to pi. It's not going to be a full cycle. It's only going to be 1/2 the cycle. I'll talk about what I mean by that in just a second. Here's my scale. Pi over 6 is going to be the first square, because that's what I'm going up by. My next one will be 2 pi over 6. If you're great at fractions, you won't need to do this, but you might write that down here and go, okay, 2 pi over 6 is the next one. But that reduces. I wouldn't write 2 pi over 6 on my scale. 2 pi over 6 is pi over 3. So if you have to write them underneath every time, you're just going up by pi over 6s, but write them down here before you reduce them. Okay, this one's going to be 3 pi over 6, which is just pi over 2, when I reduce the fraction. Then 4 pi over 6, which is 2 pi over 3. Then 5 pi over 6, which doesn't reduce, so it's just 5 pi over 6. Then 6 pi over 6, which is pi. That's as far as they wanted me to go. I left this extra space on purpose so that you see the rest of the graph, because it might be confusing what I'm going to do next. Notice that when I counted by pi over 6s, pi over 6, the phase shift is on the scale. But pi over 2, which is what I wanted to go up by, is also on the scale. That's why I use the common denominator. They'll both appear if I just use the common denominator. Eventually, once you reduce them all. Well, now I'm ready to graph. Well, okay, hang on. I'm going to take care of amplitude and period. That's the way I do it first. And I'm going to do it in orange. I think orange is the perfect color so that when I first do orange, you'll barely be able to see it. That's what I think you should do. Do one with amplitude and period, but just do it lightly so you can barely see it, so it doesn't get in your way later. Sine starts in the middle. So there's my first point of sine. That's why that assignment I did was so important. I wanted you to, at one time, build the whole sine graph. So if you got confused in the test, like, which one's sine again, you knew how to handle it. Just plug in your calculator. Sine of 0 is 0. Boom. That's where sine starts, in the middle. Then sine goes up, back to the middle. Then down, back to the middle. So after 2 pi, where's 2 pi? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I know, it only told me to graph to here. I get that. But I'm using this to go, there's the full cycle of sine. Sine does a full cycle in 2 pi. It goes up, then down and up, and it ends up back there after 2 pi. So after pi, it's here. And then at pi over 2, it's at, where is it at pi over 2? What's the amplitude? 3. Okay, so there's the middle point, 3 and negative 3. If that's confusing, you need to ask me questions right now. Like, don't wait another millisecond, because that is how you graph one full cycle of sine. And I know that this only asked for 0 to pi. And for me, I don't really care that it only asked for 0 to pi. Doing it 0 to 2 pi helped me to see the whole thing. But they only wanted this part of the loop in there, 0 to pi. Okay, that's the right amplitude and period. Any questions about that? I do the same thing on your rate of change assignment, by the way. The rate of change assignment. First, let's graph one. Yeah, I'll show you graphing one now. Okay. There's something I forgot, though. What's the thing I forgot? Well, I didn't forget. I planned it. I planned to just take care of the amplitude and period. It's the right size. It's the right shape. It's just not in the right spot. Right pi over 6. So for you, you go to a darker color. If you do this really lightly, then you go to a dark one and go, okay, here's where it actually goes. Take each of those points and move them right pi over 6. Because I chose a clever scale, right pi over 6 is exactly 1 square, making your life easier. So I take each of these points, and I'm going to go red, move each of these points right pi over 6. Did you just hear a scream? A lot of screaming in May. May is the screaming month. A lot of energy everybody has again. I didn't really hear it. Was it a silly scream or was it blood curdling? As I video all this. There's my graph. The actual one I want. There. 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 I promise I won't get nitpicky if you draw too much of the graph. This said only graph 0 to pi. I probably won't even get nitpicky if you don't put the last little bit. You should put the last little bit here, there. Yeah? Something like that. You know what I mean? Like, they said do 0 to pi. I've done at least that. I've done more than 0 to pi. There's my graph. Any questions on graphing? Is it good? If it isn't, I give you permission to panic. Yeah? Test coming up on this. We certainly need to be able to graph. Okay, the next question is where things heat up, and we actually do our review of Unit 2 coming up. Here's draw a secant line zzz, 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 your brain sizzles a little bit. It's like, okay, I did know what secants were. From the points f at pi over 3 and f at 2 pi over 3. I'm going to do that in green. F at pi over 3, right about there. F at 2 pi over 3, right about there. No, I didn't want that. I want that in green. I thought I pressed green. Did I not? Okay, maybe I didn't. Does that, once I draw it, does the memory come back? Secant for average rate of change. Just from here to here. We're just going to find the slope of this line to do average rate of change. I'll draw that on there, but you don't have to draw it on there. This is just me teaching, just to remind you. If we want to know average rate of change, we want that slope of that secant. On that day, rate of change was not hard at all. It was grade 9. y2 minus y1 over x2 minus x1. That's all I'm going to do there. That's not what that question asked me to do, just to draw the secant. Okay. I drew the secant, yeah. Then it says find the average rate of change. Well, I'm going to write a lot of stuff here. I don't know if you need all the stuff I'm going to write here. I'm going to try and review, trigger your memory, do the question all at once by writing a ton of stuff for this average rate of change question. To find average rate of change, I want the slope of the secant, which is just y2 minus y1 over x2 minus x1. That's all we had to do on average rate of change day. Find the delta y and find the delta x. But the powerful way to write it was this. F at 2 pi over 3 minus f at pi over 3 over 2 pi over 3 minus pi over 3. You're like, I don't remember that at all. Yeah, you do. You do. It's just the pi's. It's just the radians that's messing you up probably. Yeah? I wrote it as f at x2 minus f at x1 over x2 minus x1. Delta y over delta x. So I got to plug 2 pi over 3 into the function. Ooh, that's going to be fun. 3 sine 2 pi over 3 minus pi over 6. I'm plugging 2 pi over 3 into the function. Then I'm going to plug pi over 3 into the function. I don't know why I wrote an F there. That's not right. I was supposed to write 3 sine. I got thinking about the next step and wrote the wrong thing there. 2 pi over 3 minus pi over 3. Now, in a non-trig chapter, life got easy after that. You just figured out what this was. You know, you just evaluated this. But we get a little review of trig in the middle of this, of how to do these. Because you know, you're like, oh, I can just type into my calculator. Yeah, that depends. This question can be asked 2 ways. They could say to 2 decimal places. And what that's saying when it says 2 decimal places, go ahead, use your calculator. Don't worry about the next course. Don't worry about calculus. Just do it to 2 decimal places. What do we care? Or it'll say exact. And exact means, no, not with your calculator. Get this as an exact answer. Get ready for calculus in these future courses. Okay? So I'm not trying to beat you up with this, but I want to make you aware of it. This can be done. This particular question can be done without a calculator. So I'm going to do it exactly. I'm going to have faith that if this question said 2 decimal places, that you could jam this in your calculator and get the answer in radian mode. I'm going to believe that is true. If I wasn't going to do that, watch what happens here. 3 sine 2 pi over 3 minus pi over 6. I need a common denominator if I'm going to put those 2 things together. So it's 4 pi over 6 minus pi over 6 in that first bracket, or in that first term. And the second one is 2 pi over 6 minus pi over 6. And the denominator is just pi over 3. Oh, that's not so bad. It already was a common denominator in the bottom. And before you panic, now I can add those or subtract those things in there. So I get 3 sine 3 pi over 6 minus 3 sine pi over 6 over pi over 3. And I can go one more step before I start to panic. Because up till now you might be like, okay, I guess I'll try to believe you that I can do this without my calculator. But there's sort of a moment of reckoning coming here. When you get to this line, you're like, yeah, but now what do I do? You're telling me I can find out what 3 sine pi over 2 is without a calculator, and my answer is, oh yeah. Yeah. Let me show you 2 things that should have came up in the homework, but might not be perfectly clear yet. There's sort of 2 types of angles in this chapter. There's these angles. If you see a question that's got 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, any of those ones, any of those angles, you don't need fancy triangles. You don't need cast rule. You don't need anything. All you need is a decent, it doesn't even have to be that good, a decent graph of sine. And again, this is coming back to why that assignment is an assignment, not just something in class. Like, this is important. It's easy, but it's important. Here is a graph of sine. A good one? No. Just okay. Just a quick little sketch of sine. Sine looks like this. It's got period 2 pi. 2 pi, pi, pi over 2, 3 pi over 2. If this is totally mysterious, yeah, you're going to want to copy this down. Like, this should be like, this by Friday has to, or Thursday, by Thursday has to be like, oh yeah, I can make a graph of sine in 2 seconds, no problem. 1, -1. Here's a graph of sine. Maybe you're a better drawer than me. I put all the dots in first, yeah? Here it is, 1 graph of sine. And I say, with the graph of sine, you don't have to do any special work at all. Those angles have to become easy for us. When we see pi over 2 or pi's, whether it's a quick sketch or you'll see me do it in the air, I'll just in my brain, because I'm ancient, right? And I've done these a million times. I can just in my brain go, oh yeah, sine of pi over 2 is 1. Back to the other thing now. That's supposed to be easy eventually. Today? No, not this chapter. Yeah? Next October, we should be getting to the point where it's 3 sine, sine pi over 2. Oh yeah, I know what sine pi over 2 is. 3 times 1. You're like, okay. You do the little unhappy dance. My 8-year-old's great at it. Do you know that unhappy dance? And you go, oh, you're right. I don't want you to be right, but you were right about that. Sine pi over 2 is easy. Well, easy. No, it's not easy. It's easy if you know that. Huh? Next, these kind of angles. Pi over 6, pi over 3, 2 pi over 3, 5 pi over 6. Anything with 3s or 6s in the denominators. If you see those, your brain's immediately going, oh no. Here we go. Oh yeah, pi over 4s. 3 pi over 4s. Anything with 3s, 6s, 4s, and you're supposed to have done a bunch of these, which is, oh yeah, this, excuse me, and maybe this. That's supposed to trigger your brain to go, oh yeah, 3s, 4s, and 6s, start drawing. Here we go. This one isn't quite that bad though, because it only asks for pi over 6, is it? Sine of pi over 6, I don't need to draw it. I don't need to do anything special, because it's right in the special triangle. Pi over 6. Sine, opposite of hypotenuse, is 1/2. Where was I? Over here. And again, now's the time for your unhappy dance where you're like, oh, maybe you're right. Maybe this can be done. Yeah? Easy? No? Very triggy. tricky. Lots of steps. Lots to know. We're running out of space here. Oh, and it's not letting me scroll. I'll have to fit this in down here, okay? So final couple of steps. Actually, I'll do a fancy sales pitch for getting yourself an iPad to do notes. Watch what you can do. Just grab all that and go, oh yeah, ran out of space? No, I didn't. Yeah? You can't do that in your regular notebook, can you? Huh? You can actually make these really small and just zoom in them when you need them. Anyways, okay, so the top I get 3 minus 3 halves over pi over 3. 3 minus 3 halves is 6. I'm going to show all the steps here, if it's stressing you at all. 3 halves times pi over, times 3 over pi. 9 over 2 pi. Good. Lots of fraction work there. This really isn't trig down here. But this is why trig can get a bad name sometimes, is because if you don't know your fractions, things can go a little haywire on you. You see that okay? 9 over 2 pi down there? What did I do? I got a common denominator. I subtracted those two fractions, switched it to division, multiplied by the reciprocal, way you go. I'm not trying to act like that's supposed to be easy. I'm not. What I'm trying to say is that's not trig. That's fractions. Okay? That's if they want it exact. If they say to 2 decimal places, you can do that right here. Do in your calculator, boom, answer. This course really is about 2 decimal places, but we're trying to get ready for exact. Question. That's not a radical, it's a pi. But you're right. Final check at the end is like, wait a minute, is there a radical there? And in this chapter, what I do is, if it's an easy question and you leave the radical, sometimes I'll take a part mark off. If it's a really tough question and there's a radical, then I'll do the happy dance or the unhappy dance where I'll be like, oh, you didn't get the radical. Okay, I'll still give you all the marks because it was a tough question. You know what I mean? Like, I try and find that middle ground in this course. Yeah? That's not even a tough question. You can see it was made difficult because of trig, though. Back in when we were doing this in chapter 2, it wasn't a big deal. We just simplified the numerator, simplified the denominator. We would have been done right here. It wasn't particularly hard then because the numbers weren't crazy like the pi's and the root 3s and the 1s over 2s and all that kind of stuff. Questions there, though? Do you know what's coming next? Oh, you're peeking. That's why you know what's coming next. Is that a blank page? Find the instantaneous rate of change at pi over 3. I'll go back to the picture even though it's not very helpful. At pi over 3, right there, I want to know the slope of the tangent line. Right there. I'm going to draw a new diagram on my other page. A big diagram to remind you how this all works. And I'm going to use method 2, even though you could use method 1 here. I don't remember either method. All right, here comes method 2. Method 2 looks like this. You draw a little fake picture like this to try and help you. You have your initial point, which is at pi over 3, comma. Well, I'll leave that blank for a second. I'll let your brain work on that for just a second. What goes there? In fact, I think I'm going to need a bigger bracket. And then I'm going to choose some other point along the curve. But I'm just going to call that x comma something. Now we got to see if somebody sort of remembers this. Now that I draw the diagram, do you sort of remember? How am I going to get the y value of the point that they gave me? What do I do with the pi over 3? I tried to bore you with this in chapter 2. Say it a million times, hoping that it would stay in there now. What do I do with the pi over 3 to get the y value that goes with it? Just sub it in. Yeah, just sub it into this 3 sine pi over 3 minus pi over 6. I think I already figured that out. Did I, on the previous page? 3 sine pi over 3 minus pi over 6? It's this one here. It was 3/2. Yeah? So you can try that again as an exercise, but I think you'll find that that point is just the 3/2 that I did on the previous one. This one, I just write the equation. X minus pi over 6. Like that. I just use that straight equation. And what I'm doing is setting up a secant slope formula. Here it is. M secant. It's just y2 minus y1 over x2 minus x1. Is this coming back to you? How long ago is this now? When did we write this test? Let's see. Unit 2. We started this class in February. Probably around February the 26th or something like that. Yeah, so it's going back a little bit now. So don't judge yourself too harshly if you're hard to bring it back here. So M secant. Anyone panicking out there? This is not on the test. I didn't put it on the test this year. It's on a separate assignment. So you'll have time to go, how did this work again? And it's not even due the day of the test. I made the assignment due like, so we got time to work all this out. Okay. Numerator, 3 sine x minus pi over 6 minus the 3/2 all over x minus pi over 3. Some of you got great at common factoring, canceling, all that kind of stuff. Trig is not cooperative like that. It doesn't do any of that factoring stuff nice. That's what we're going to use, that equation. So you're going to have to get your calculator out and really type this in, which I'm going to do and show you how to do it again here. So then I set up my table, and I got to put things that are close to and getting close to pi over 3. Now there's 2 choices of how to handle this. I'll show you the first way, which I don't like at all. You could get your calculator out and get pi over 3 as a decimal. Let me find my calculator. Where did I put my calculator? I could go into, I'm not in radian mode. Okay, so radian mode, I could get into radian mode, and I could, I don't need to be in radian mode for this, but I could go pi, where's my pi button on this one? Pi divided by 3. And it says pi over 3 because I've got a great calculator. Maybe you got a great calculator that's not being cooperative. For method, one way I could do this, I could get that as a decimal, and I could say, oh, let's just use this as 1.04 719 7551. You could use that as your x value and then just get closer and closer. You could do like 1.05, 1.0471. You could just get closer and closer. That works. It's perfectly fine. You could do that. I'm not going to. I like this better. I want to get close to pi over 3, so I'm going to do my x value of pi over 3.1, pi over 3.01, pi over 3.001. I think that's clever. And allows my calculator to do all the work for me. But if that's too complicated for you, you go ahead and do this. Do it with a decimal. Yeah? And I think this is easier to type in. Maybe I'm just being lazy, actually. Here I go on my calculator. I forget, does this one show fractions? Please be a fraction calculator. Oh, it does. Oh, it's time to upgrade, folks. It is time. Yeah, it's time to let it go. Let that old calculator go if it doesn't show fractions like this. Just so much easier. Here's the numerator. 3 sine, open bracket, x, I'm using pi over 3.1, pi divided by, ooh, wait, does it do fractions in fractions? I don't know if this one does. Let's check. Backspace. Can I do a fraction inside a fraction? Oh, yeah. It's good. So nice. Pi over 3.1. Okay, what was it doing? Pi over 3.1. Pi over 3.1 minus pi over 6. Oh, I love this. You have no idea. You have no idea what we went through when I was a kid. I know you don't like when I was a kid stories. You should have seen us trying to type these things in our crap calculators. And then minus fraction 3/2. There's the numerator. It looked like it was going to be bad, but yeah, it is bad, but my calculator's taking care of it all for me. Then the bottom is fraction. Oh, I hit fraction twice there. That's not good. Oh, now I'm in trouble. Oh, now I'm in big trouble. Can I survive? There's the numerator. Close the bracket. Then hit the fraction button. Am I going to get away with it? Yes, I am. Okay, good. Then the denominator. Type more carefully, Mr. Todd. Pi fraction 3.1 minus pi fraction, what was it, 3? Looks pretty good. Equals, you type it in, see if you get the same as me, 2.622, it disappeared on me, 915133. Did you get that? Did you type it in? Who typed it in? Cameron, did you get this? Yeah, okay. You're like, oh, that was awful, typing that all in. You'll be happy now, because now I'm just changing it. I'm getting closer to pi over 3. I'm going to go pi over 3.01. Then I just have to go back and change all those 0.1s to 0.01s. Almost there, almost there. 01, 2.600. 680.264. And I'll do one more, because once I got it all typed in there, I may as well do a couple. You should do 3. I think that's what we decide in Unit 2. Do at least 3. 2.598. 337871. Therefore, IROC is approximately, geez, I don't know, are we happy with that? Did it settle down enough for you? Are you happy with 2.6? Maybe you're not. We'll go one more, just to be sure, just to feel good about it. We'll go back and go, maybe we'll go 2 more decimal places. O. And then over here, one more O. 2.598. Now I'm feeling pretty good about 2.598. Equals approximately 2.598. It settles in at 2.598 when I do that next one. Does this ring a bell in general? Yeah? Even though playing with the pies, I get it. That's a new challenge. The good news is it's on the assignment part of the evaluation, not the test. So you don't have to be fighting with this on the test on Friday. Questions there?